Hi, dear students. For this semester, I am going to help you out to understand few concepts in organic chemistry. I am assigned to teach you the first chapter of your subsidiary chemistry paper for your second semester. So, organic chemistry, you have learnt a little from your senior secondary classes. So, the question is, what is organic chemistry? Before asking that question, we must discuss what makes carbon atom to have a special branch of chemistry. The answer is the property what we call catenation. What is catenation? What is catenation? Catenation is the ability of carbon atom to link with other atoms and to the carbon atom itself to form open chain structures and ring structures. So this is a special property of carbon atom. 14th group elements possess this catenation property. As you move down the group, this catenation property decreases. And what makes carbon to have this special property? It would be because of its small size and its ability to form multiple bonds with themselves and with the other atoms. And it's moreover that its tetravalency. All these are the reason for the catenation property. So that makes carbon to have the ability to form millions of compounds. The most important reason that makes the life to exist on the earth. So carbon has got its own branch of chemistry, that's what we call organic chemistry. Now, what is organic chemistry? Organic chemistry is a branch of chemistry which deals with hydrocarbons and their derivatives. So, what is hydrocarbon? Hydrocarbons means the compound which contain carbon and hydrogen only. So hydrocarbons are the compound which contain carbon and hydrogens. So if you take any compound, organic compound, all of them are basically built up from the smallest compound, that is what we call methane. So when I was teaching chemical bonding, I have mentioned about methane. You could consider methane as the father of all the organic compound. All it is the cutest baby of organic compound, because all other organic compounds are derived from this particular compound called methane. So methane belongs to the class of compound called hydrocarbons. So how do you build up all other compounds? So the organic chemistry is the study of hydrocarbons and their derivatives. So the CH4 we can write like this, CH3H, and this H could be replaced with many other elements. Suppose if you are replacing with carbon, so you can't replace with carbon, carbon's valency is 4. So you must replace with the CH3. So you get CH3, CH3. Suppose you wanted to replace with this hydrogen, you wanted to replace with OH. You know, OH represents a class of functional group, is what we call alcohol. So you get CH3OH. And you can replace this hydrogen with CHO. Then it is CH3CHO. We call it as methanol. an aldehyde. You can replace with CN. This could be replaced with the CN. Then it will be CH3CN. We call it as methane nitrile or methyl cyanide. So that's how all other organic compounds are derived. So let's take a particular compound. Suppose if we are replacing this hydrogen with carbon, then what will happen? So we have taken CH4. One of the hydrogen could be written as like this. CH3H. This hydrogen is replaced by one more carbon. So it will be written as CH3CH3. Now you can replace it with one of the hydrogen from this could be replaced with another carbon. So it will be CH3CH2CH3, and you can keep going. So CH2 CH2 CH3, and the next one CH3 CH2 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 CH3. What is the speciality of this compound? If you take two adjacent, the compound, this is a series of compound. If you take two adjacent members, you could see the difference between these two will be CH2. And you can see all of them are having same type pattern of the formula, molecular formula. And you can take one more compound. Suppose if you have taken CH3H and this H is replaced by OH, then it will be CH3OH, CH3CH2OH, CH3CH2CH2OH, CH3CH2CH2CH2OH, CH3CH2CH2CH2CH2OH. Now, if you take the molecular formula of this compound, this is CH4, this is C2H6. Like that, if you keep writing CH4, C2H6, C3H8 and C4H10, C5H12, like that it keep going. And we have already discussed the difference between two adjacent molecules of this series, this family is CH2, and you can represent this formula. So CN H2N plus 2. The same way here also you can take the difference between two adjacent molecule will be CH2. You can even take the atomic mass difference will be 40, and it could be represented by a molecular formula, that is CnH2n plus 2O. That is the molecular formula, the general formula of this set of compounds. So you can build up many families of compound like this, and this families of compounds or series of compound could be called as homologous series. So what is the speciality of this homologous series? Number one, they have successive members by differing with the CH2 group. They have a general formula. If you take the second set of compound, which is alcohol, you could see that they have same functional group. We'll discuss about functional group. When there is a functional group, same chemical property. And as you move down, you could see that there is an increase in the atomic mass 14. So the physical properties depends on the atomic masses, but it will be looking like similar. So it's actually identical chemical properties, whereas physical properties will be similar physical properties. That's how you must say. So if a series of compound possess this particular property, this set of property we call it as homologous series. Then what is homologous series? Homologous series is a series of compound, could be represented by a general formula. Successive members differ by CH2, will have same functional group, and so that the same chemical properties and similar physical properties. So this series of compounds are what we call homologous series. Now, what is a functional group? I have already told you all the organic compounds are derived from the hydrocarbons. And how the hydrocarbons are derived to some other group or some other members of organic compounds, if you ask, the hydrogen atom will be replaced by some other members. Suppose if you are replacing by OH, then you will be getting CH3OH. If you are replacing with an atom, that is chlorine, you will be getting a halide. So this is called methyl halide. If you are replacing with CHO, you will be getting CH3CHO. We call it as aldehyde. Then if you are replacing with COOH, this is what we call acid. So this is methanoic acid. So if you replace this hydrogen atom with an atom or group of atom, you get a different class of compound. Why do I say different class of compound? These compounds are having different chemical properties depending on what is the species. Depending on what is this species. So I stress the species are very important because this set of species determine the chemical properties of this compounds. So we were discussing about homologous series. There is a functional group. What is that functional group for? It determines the chemical properties. So what is functional group? So it could be like, what is the speciality in elephant? So when I talk about elephant, immediately the trunk will be coming to your mind. If I ask what is speciality, what is the special organ of a bat? For a bat, its ear is very important. For an eagle, its eye is very important. For a dog, it's not the tail, it's the nose that is very important. So, when I talk about a particular animal, a particular organ will be coming to your mind because that is the most special organ of that animal that determine most of the properties of that particular animal. The same way, in organic chemistry, for each compound, there will be an atom or a group of atom that determine the chemical properties of that compound. That is what we call functional group. So what is a functional group? A functional group is an atom or a group of atom that is responsible for the chemical properties of that compound. Hope you understood what is functional group. So, I need you to do a small exercise. What is that is? You have to take an A4 sheet and you have to draw 3 columns and collect as many functional groups as possible from various sources. It could be the internet, it could be the textbook, NCERT textbook, all. And you need to write down what is the name of the functional group. For example, I am writing carboxylic acid. And the structural formula is like this: COOH. Detail. And the short representation will be like this. So you have to perform, like you may get around 20-25 functional groups, and you have to write down their name, structural formula, and the short representation. This is a small assignment for you. There is one more in this slide, in this video itself. So you have to take a photo of that and upload into the Google form. I'll share the link of Google form. Now let's look into how the organic compounds are classified. Classification of organic compounds. Basically, the organic compounds are classified as open chain and closed chain compounds. I have already told you about the catenation property. So the catenation property is the ability of carbon atom to link with other atoms and the carbon atom itself in order to form straight chain compounds and ring type compounds. So basically, organic compounds are classified as open chain compound and closed chain compounds. The open chain could be called acyclic or aliphatic compounds, and the examples are alkyne, alkene, and alkyne. Alkane, completely saturated compounds. Saturated. And alkenes and alkynes are unsaturated compounds. So the saturation means there is no double bond. All the valencies are satisfied by hydrogen atoms or some other atoms. It's like carbon valency is 4. If all the valencies are satisfied by the sufficient number of atoms without making a multiple bond is what we call saturated. It's like the stomach is filled. And if there is no sufficient number of atoms, the carbon will go for multiple bonds like double bond and triple bond. Then it is called unsaturated. The stomach is not filled. Once your stomach is filled, you can say you are saturated. So now this is unsaturated. So the open chain, acyclic, alkane, alkene, and alkyne. Then if you take closed chain, that is cyclopropane, cyclobutane, like that could be classified into homocyclic and heterocyclic. Homocyclic means the ring will be made out of a single atom. That is when you are discussing about organic chemistry, carbon atom. Heterocyclic means instead of carbon atom, there will be some other atom. You could see here oxygen, you could see here nitrogen, you could see here sulfur. So then it is called heterocyclic. This is an example furan, this is an example pyrrole, this is an example thiophene. Now this cyclic compounds are classified. This is the cyclic compound are classified as alicyclic and aromatic. Alicyclic means it could be having double bond, it could be having triple bond. They are cyclic. They may show the properties of alkanes, alkenes, and alkynes. That's it. And whereas another set of compound, we'll discuss about that set of compounds, that is called aromatic. Aromatic has got a history background. Aroma means smell. This particular class of compound will give a particular smell. That's why it is called aromatic compounds. Aroma. Actually, in reality, it's they have got the when you talk about aromatic, they are characterized by an extra stability. Aromatic compounds are highly stable. That excess stability made them to get the name aromatic. That's how scientific fact. We'll discuss about it. And the aromatic compounds, there are two type of compounds. One is benzene type. Benzene type means, you know, benzene, it will have a skeleton of benzene. Non-benzenoid means they may not be having the skeleton of this benzene, but still they are aromatic. Those type of compounds are what we call aromatic compounds. And the next it is hybridization of the organic compounds, because hybridization is very important. When you wanted to discuss about the chemical properties of the organic compound, you need to know what is the shape of the molecule and what is the electronic structure. All this could be understood by hybridization. We have discussed about the hybridization of CH4, CH3, CH3, CH2, CH2, and CH. This is methane, this is ethane, this is ethene, and this is ethine. We have already discussed about them. And the second assignment is you need to go through those videos, the previous videos, where I have explained about the hybridization of all these compounds, and you need to draw orbital overlapping diagram for ethane, methane, ethene, and alkane, and you need to upload it into the Google Classroom. I will give you the link. So you have got two assignment. One is the regarding functional group. The other one is regarding the orbital overlapping diagram. You have to draw orbital overlapping diagram for all this four compounds. I have told you what are the steps to be followed. Okay. Thank you for hearing me.